Hi everyone, thanks for watching. In this video, we're going to go over some of the calculations that you can do with specific heat capacity. Now, before we take a look at the math, just take a minute to remind yourself what you observed in the sand and water example. Even though the two substances absorbed the exact same amount of heat, the temperature of the sand changed a whole lot because its specific heat capacity is much lower, meaning it doesn't take very much heat to raise the temperature of sand by the same 1 degree Celsius as it does compared to water. So now let's take a look at the equation we use to calculate specific heat capacity. The first part of the equation is our lowercase letter q, which means heat energy. The heat energy is equal to, the first thing that gets plugged in is the mass of whatever object is releasing or absorbing that heat energy. Then we have a capital letter C, which is the symbol used to represent heat capacity itself. Finally, we have delta T, which means change in temperature, because of course if the object is absorbing or releasing heat energy, its temperature is going to change. And just remember, when you calculate change in temperature, you should always do final temperature minus initial. That's going to be really important for getting the proper negative or positive sign on your heat value. And there's just one more thing you need to pay attention to, which is what units should get plugged in for each of these variables. The best way to understand that is to look at the units on specific heat capacity itself. Those are joules, which tells you that your Q value is going to be in joules. On the bottom of the fraction is grams, so your mass should probably be plugged in as grams. And lastly, degrees Celsius, which means your delta T should get plugged in as degrees Celsius. So let's take a look at two quick examples to show you how to apply this equation. The first one should sound pretty familiar. What if you heated 100 grams of water on a hot plate for 5 minutes, and its temperature changed from 22.3 up to 27.6 degrees Celsius? With mc delta T, we could solve for how much heat energy was transferred to the water in this scenario. So let's start plugging some of these numbers in to see what it looks like. First of all, we're solving for the value of Q. So the first thing I need is a mass, and that was given to us in the problem as 100 grams, so we can go ahead and plug that in. The next thing we need is the specific heat capacity. Now that's dependent on the substance, which in this case is water. And the specific heat capacity is usually just given to you in the problem. This one doesn't provide it because I'm going to. Water's heat capacity is 4.18. And then remember, the units of the specific heat capacity is joules per gram degrees Celsius. The last thing we need is a delta T, which is also given to us in the problem. Just remember to always do final minus initial. So in this case, we would have to do 27.6 minus 22.3. All that's left is to subtract those, multiply everything together. Notice how the units cancel off, grams, grams. I didn't write in degrees Celsius, but those are going to cancel off too, so our final answer will come out in the units of joules. And after you do that, you should get 2,220 joules that was transferred to the water to cause this temperature change. Now the cool part is you can use that same equation to solve for any of the variables in there. It's not always just solving for Q. So if you had 50 grams of sand that you heated, and you knew that the sand received a certain amount of Q, the same 2,220 joules as the water did, and you measured its temperature change, then you could find out what the specific heat capacity of the sand would be. It's pretty much the same thing, just plug in the values that you were given and solve, but this time for the C value of the sand. Here's what that would look like. So plugging in all the variables, I've got my joules, my mass, and my temperature change final minus initial. Now I'm going to go ahead and solve for C. And since this is all multiplication, to get this C value all by itself, I'm going to divide both sides by the 50 and the change in temperature after you subtract, which is 53.5. That means I'm going to have to do the same division step over here. So on the right hand side, the 50 grams will cancel off. Delta T's will cancel off, and I'll be left with my specific heat capacity equal to that division right there, which comes out as 0.83. Now notice the units, we've got joules divided by grams, and I forgot to write it, but that would be degrees Celsius, which is supposed to be the units on specific heat capacity. So hopefully this helps you before you attempt to do some of these calculations on your own.